Alright, let's see here. Each node in the n array tree contains a val, which is an integer, and a list of nodes of its children. Okay, so basically, 1 is going to have a list of 3, 2, and 4 references, and in this case, 1 is going to have 2, 3, 4, 5 inside of its list, and then 3 is going to have 6 and 7, 7 is going to have 11, 11 is going to have 14, 14's list is going to be empty. It says the depth of the n-array tree is less than or equal to 1000. So that means I can use like something that is memory intensive. Like I'm already thinking a hash map, because usually when you copy things that require some sort of graph, I just think of a hash map immediately. But the only problem with the hash map is that it's really memory intensive. So it's good that they tell us that it'll only be up to 1000 nodes in depth, which means that there is a good decent limit to the amount of memory that we'll be using if we use the hash map. The total number of nodes is between 0 and 10 to the 4th power. I mean, it's not terrible for a computer, so I think it's fine. So yeah, just gonna go with the hash map implementation. I'm already thinking about that. So basically, every time I see a node, create. First of all, I need a. Let's just say, I don't know. Well, okay. Yeah, I'm gonna create a scene, a map, and this is basically just gonna map I'm gonna call it an old node to a new node. Basically, is what's gonna happen here. So if I map an old node to a new node, then when I copy 1 over, let's say I copy 1 over, that's great. And if I copy 3 over, how do I know where to put it in terms of inside of the copied version? How do I know where to put it? Well, I'll know that my 1 is my parent. Maybe if I do this starting at the 1 node, I can check 1 and go 3 to 4 for each one of these. I create a copy of it. I put it inside of the scene. I map from old node to new node. And then maybe just throw it into a stack for a breadth first search. So this is kind of like a combination of BFS, as it's going to use a map. I'm just going to copy this here. And this is basically the goal. This is what I'm going to end up doing. Cool. So I'll start with the empty dictionary. I'll copy over the root node. I'll call it new root. And then I guess I'll call it, I can say down here current old. We started at root. I'll start at root current new. I'm gonna say that's none for now. Well, actually, I'll say that's new root. Okay, or I can just do this. Get rid of this whole thing. So yeah, current old is going to equal to the root node, and then current new is going to equal to the newly created copy of a root node. Okay, and then while current old dot left and current, I guess I could say or current old dot right. Basically, as long as the current has a child, or since I'm doing breadth first search, never mind. Since I'm doing breadth first search, I might as well just do, let's just say, in breadth first search, do I do a queue or a stat? Yeah, I do a queue. and then I'm going to throw on the current old onto it. And then while the length of the queue is greater than 0, basically while it's not empty, I'm just going to throw, I'm going to pop off the stack. I have to pop 0 for it. So yeah, while the length of the stack is greater than 0, I pop the top node from the stack and put it inside of current old. So let's just say that I start with this 1, because that was on the stack. It was the only thing on the stack. What I need to do now is for every, let's just say for child, for old child, that's a oxymoron, for old child in current old dot children, right? So for every child, essentially, I have to create a copy of this child. Something I should have done here, though, is map scene at current old. Okay, that's just that needs to be done. Okay, so for every single child inside of the array for the old children, I need to create a new child, and I need to map that old child to the new child. So I need to find, first of all, I need to find new current new. I need to set this equal to the equivalent of the current old, because I need to be able to talk about the same node here in order to, so, you know, let's say like I was somewhere down here in like the 8. How do I know where this 8 is in the copied version, right? Let's say I get to this 8. I need to find where that 8 is in the copied version so I can add the children to 8, the copied children to that copied version, right? So I need to add the 12 to that 8. The 8 exists because I already copied it in some other copy of this entire tree, but at the same time, I don't know where that 8 is, so I need to keep track of where that 8 is using a hash map. So I find that 8, and now I know, make that 8's child a copy of this old 8's child. So the current new is going to be, I'm going to check my hash map. So it's going to be seen at current old. So if I was at this 8, which is in this case the current old, 8 is the current old, I would say give me the new version of that 8, and in the copy of this entire hash map, of this entire tree, I would find that new 8, and now I am ready to clone this child 12 and put that clone as a child of that new 8. So I'm ready to clone the child 12. I can create a function for this, but I don't really need to since it's not that many lines. I think we need to do it in 1 line, right? Let me just say new child is going to equal to, okay, well, also here's the thing. Whenever you create a list, whenever you create a node, the list in that node is set to none and not an empty array. So first I need to check to see if the children inside of that node is none before I try appending to its list. Because if that list doesn't exist, then it's going to throw an exception saying that list doesn't exist and I can't append to it. So first I need to check to see, I even need to check to see if that current new, so if current, again, I only do this though if there is a child, so, well, but I'm doing this for every single child of the, yes, this needs to be up here. Yeah, so for every single child of the old, I'm going to add current new to it. So I'm going to make it current new's child as well, but a copy version of it. So current new, sorry, if current new dot children. Remember, if I created current new, but it doesn't have children yet, then it's going to be a none. So, children of children is not none else. Oh, that's so fucking stupid. Okay. So, they could have literally just put these square brackets here. So, they do initialize it to an empty list, but for some reason, they just decided not to put it here. Because what it says is, make it children, set children equal to the past in children if children is not none. Okay, in this case children will be none because I'm not going to be passing in anything here for when I create a new node. So if it is none, then it's just going to create an empty list, which is great. Awesome, that's what I need. So I don't need to do this if statement anymore. I know that I can just do this. Current new dot children dot append, right? I'm just going to append to that empty list, or if it already has things in it, then I'll append to the partially full list. So I'll append a new node. In this node, it'll be the old child dot value. Boom. So all I'm doing here is breadth first search with this queue and iterating while the length of the queue is greater than 0. So that's breadth first search component to this. The second component to it is to make sure that whenever I create a new child, I need to add it to the dictionary. So let me do that now. Actually should just be a new child now. Awesome. So yeah, every single time I create a new child, I need to add it to the list or the map of scene mappings between old and new nodes. And finally, I need to add that new child as a child of the current new node that we're looking at. So this will be in addition to a list, an append to a list. Of course, I need to keep track of my root node because I believe that is what I'm going to be returning. So, let me create that here. Yeah. No, it's at line what? 20? They're saying that cur doesn't exist because there is no cur, you're right. It's current underscore new, not current dot new. Didn't they used to have like a tree visualizer? Oh, is it this case? Yeah. Yeah, that is this case. So I got the one null 3 to 4. Okay, 3 to 4, and then I missed this subtree. Oh, because I forgot to add it to the queue, obviously. Yeah, every time you see a new child, you gotta add the old child to the queue. Oh, this is the case where I don't even know what to return in that case. What are they expecting? Maybe none? Okay, I guess that works. Cool. So let's see how other people did it. Python one-liner. Alright, bro. Okay. Oh, he did a recursive function, which is great, but I prefer not to do recursive functions because whenever you do a recursive function, they always end up asking to do the iterative version anyway, so there's no point. Unless it's like a really hard problem to do iteratively. Another recursive function. This person actually used the depth for search. It looks like this one was actually iterative, but he didn't do iterative for this one. See, I don't understand why people are so afraid of doing depth for search iteratively. Let me sort these by most. Oh, it was already sorted by most votes. Okay, fine. Let me just exit out of these. Okay, let me refresh. Awesome. So these. Next one. What the heck is this? Clone a binary tree with random pointer. Oh my goodness, I remember the clone. See, the hash map trick that I just used is a trick that I learned from the clone a linked list with the random pointer. But clone a binary tree with the random pointer was interesting. Okay. So a binary tree is given such that each node contains an additional random pointer which could point to any node inside of the tree or null. Return a deep copy of the tree. The tree is represented in the same input/output way as normal binary trees, where each node is represented as a pair of val and random index. Okay. See, I mean, I don't know what it means to be represented as a normal binary tree because, like, there are a lot of ways people do it. So val as okay, random index. So index. What is this stored in an array? Is that why? No, it's not stored in an array. Okay, whatever. I don't know what they mean by index then. Because the random is just actually should be a type node. Anyway. Random index, the index of the node in the input where the random pointer points to, or null if it does not. I think it means like a reference to the pointer, not an index. I don't even know who wrote that. Okay. You will be given a tree in class node, and you should return the cloned tree in a class node copy. In class node copy. Class solution, but it's not class node copy. A copy is class is just a clone of node class with the same attributes and constructors. Are they sure though? Because they gave me a class called solution, unless they want me to create a new class. But there is no node copy class. I think this question was just written really shitty, but I think I understand what they're trying to get at. Basically, they're giving me a binary search tree, and I need to figure out how to create a deep copy of it, where one of the attributes is a random pointer to a random node or null, but a random node may be inside of the tree. So, I mean, this doesn't really seem that bad, if I'm going to be honest, because I already did the linked list version of it. So, this one right here, the root node, let's say I create a copy of it and I store the copy from the old to the new inside of the hash map. And then I go down here and then I store a copy from the old to the new in the hash map. And then I go down here, I store the copy of the old to the new, okay, but along the way, let's say, okay, this random is null, but let's say we're taking this random, for example, we could run into two situations. One situation that we could run into is where the random pointer points to a node that we haven't created a deep copy for yet. And then the second situation is where we have created a deep copy for that random node. So how do we know if we've created that deep copy? I think that's where the trick in this question is. How do we know a random pointer node? Right. So the only way to see if you've created a well, first of all, you could see where this points to, then see if this nodes is inside of the map. And if it is, then that's great. We use whatever that points to in the map. If it's not, then you have to create it, throw it in the map, and then, you know, so that means whenever you get to a new one, whenever you're going down here, you don't automatically create a new node for the deep copy. You first have to check to see if that node was created somehow through the random pointer process. Honestly though, this question seems pretty easy. I'm not even gonna do it. In fact, it's already getting kind of late. I'm just gonna log off. But thanks for the few people that stuck by. I'll be doing more of this Leetcode stuff, not because I need a job, but just because I find it interesting and I don't want to lose the skill. Alright, peace.